Hello again, class. We are still in our study for lines, linear equations, and all of that, but now we're going to look at the point-slope form of a linear equation. So in our point-slope form, we again use our x1, y1, x2, y2, two different points on the line, just like we would in our y equals mx plus b form that we just did in the last lesson. However, here, our y1 and our x1 are two different coordinates that we know, and our slope we also know. So let's go ahead and take a look at this. So feel free to refer back to this at any moment that you need to. So when we look at how this works or why this works, let's stick on this example for just a moment. So if we see here, we can look at the rise versus the run, and we can find the slope here to be 2 over 1 or just 2. We can then look at this point, our x1, y1, and see that that actually is at 2, 1. So here's how this works. I can label another point on this graph just by knowing our slope formula, just by knowing what I have here. Because I know that our slope formula, our m, is equal to the change in y to the change in x, I know that my change in y needs to be a positive 2, and my change in x needs to be a 1. So I can go from my first point to 1, I can change my x by 1 and my y by 2, and then I end up at point 3, 3, which if I look here on the graph, boom, 3, 3 is a point on the graph. I can do this again. I can change the x by 1 and make it 4, change the y by 2, make it 5, look at my graph, and in fact, there's 4, 5. There's another point on my graph. I can keep doing this just by understanding the slope formula. Okay, all we are worried about right at the moment is being able to write things in the point-slope form. So to do that, we need to remember what is point-slope form. So you could either go back in the video, back in your notes, or if you remember, it's y minus y1 equal to the slope, which we represent with m, multiplied by x minus x1. Now really quickly, how we get here derives from the whole slope being equal to delta y over delta x, and then we can say it's y2 minus y1, x2 minus x1. You can cross multiply and get here that way. So if we know our point 8, negative 4, and our slope 2/3, go ahead and try to put that into this form. So remember that it is the y1 and the x1 that is the point that we're given, and then x and y are just any other point on the line, which we don't know right now. So we plug in our y1 and our x1, and we actually see that minus a negative 4 will give me plus 4. And then we can simplify over here. We could distribute the multiplication, but that doesn't really make things easier. So we can just leave it in this form. This is our equation written out in point-slope form. Except for the fact that the only thing we're missing is filling in the slope, which we also know. So if we input that correct slope, our slope is 2/3, so we substitute that into here, and now we can leave it just like this. Go ahead, pause the video, try with both of these. Now the biggest mistake I ever see with these is putting the x and the y in the wrong locations. So what I do to help me out with that, at least when starting, is I really small above these just write x and y, and you can even label those x1 and y1 if you want, and you could do the same thing down here. So now pause the video and try to write these in the point-slope form. For our first one here, we plug in that our slope is the negative 5/3, our y value is 2, and our x value is 4, so we can leave it just like this. If you have not done number 2 yet, pause the video and do that now. What we see here then is, since I have negative x and negative y values, this gets a little bit complicated for a second. So I have y minus a negative 7, so I end up having to write that y plus 7 equal to the 4/5 times x minus a negative 2, so that becomes x plus 2, but you gotta remember that that x plus 2 has to be in those parentheses, because if we were going to get rid of those parentheses, we would have to distribute the 4/5 through multiplication. Alright, so before we can actually approach a problem where it asks me to graph the equation in point-slope form, you need to really remember that this is y minus y1 equal to the slope times x minus x1. So the slope is easy. Slope here is obviously negative 4/5, but it's the x and the y point that make it hard, and you have to determine that point before you can even start the graph. So all right, let's write it down. We know slope is negative 4/5. Always good to write down what we know so we don't forget what we know. Then the point that I know, because this is minus y1 and minus x1, if I look at the sign in front of it, my positive 7 and my negative 4, those are actually going to be the opposite of the values that I want. So if I think about my point, it's actually the opposite of negative 4, or just the positive 4, because it's minus x1, so x1's just the 4. And then this positive 7, well, since that's actually minus a negative 7, it must be, then this y value is negative 7. So what I like to do when I'm using point-slope form is just look at the sign in front of the number and take that whole thing and do the opposite. Take the sign in front of the number, whole thing, do the opposite. So we have 4. So because I know that I'm going to have 0.4 and negative 7, I'm going to need to go right on the x-axis and down on the y-axis. So I want to draw my origin somewhere up here near the top left. So go ahead and put your x and your y axes. So here we've got the point plotted at 4, negative 7. Now it is sometimes helpful, you don't always have to do this, but make sure that occasionally when you're graphing, you remember that you want to put the scale that you're using. So that's a positive 1 and this is a negative 1. So I can write that scale real fast. So this is 4, negative 7. Now my slope is negative 4, positive 5. So that'd be my change in y over my change in x. So my y, I'm supposed to go down by 4 and go to the right by 5. I can't really do that. So instead, I could think of this slope as being a positive 4 over a negative 5, which then tells me go up 4 from where I am and go left 5 from where I am. So when I do that, I go up 1, 2, 3, 4. I go left 5, which is actually going to take me beyond the y-axis, which is okay though, because I can still connect them. And there's my point out there at negative 1, negative 3. I can also think of that as being my change in y, change in x. What happens when I change my y by positive 4? I get a negative 3. What happens when I change my 4 by a negative 5? Well, I get a negative 1, which takes me right to that point that we just put on my graph. Once I have 2 points on my graph, I know that I can connect them with a straight line to make the graph. All right, I missed the point just slightly down here, but if you can imagine that my line is actually perfectly where it's supposed to be, then there we go. And then we can figure out the equation of our line if we need to, but we don't actually need to because it's just asking us to graph. If you looked at the Pearson lesson, you would have seen problem 3, but in case you did not, problem 3 is asking us to use these 2 points to write the equation. Now I know that I can use one of these points as my x1, y1. Sorry for the bell there. But what I really need to do first is find the slope of this line. So again, to find my slope, it is delta y over delta x. So go ahead and see if you can set up the math with these 2 points to find the slope of this line. Pause the video and try. Alright, so when I set up delta y over delta x, I take my y2 minus y1. Again, it doesn't matter what order we do this, and I could flip these around and I'll end up with the same points, or the same slope. And then I take my negative 2 minus my 1. Now pay attention, if my negative 3 comes first, my negative 2 has to come first. If my 4 comes last, my 1 has to come last because they have to agree with each other. So I get a slope of 7/3. So now that I know that, I can choose either of these points. So let's just say I'm going to choose the one with the positives, the 1 and the 4. So we can then write y minus the y that we have, which in this case is 4, equal to our slope, 7/3, all times our x minus 1. And that is how we take 2 points and write it in point slope, because all we have to do first is find the slope. So if we were going to write the equation of this line here at the right, we've got a point 1, 4, we've got a point negative 2, negative 3, but the first thing we actually need to do is find out the slope. Now we can do that through our delta y over delta x, but actually because it's on a graph, it's even easier than that. We can just go from point to point and use our triangle method to find the slope. So pause the video for a second and try that. Figure out the slope just through investigation. Now we can draw the triangle. We can also check our math from my y down here, negative 3, to my y up here, positive 4. That is a positive change of 7. And then from my x of negative 2 to my x of positive 1, that is a change of 3, which leaves my slope being a convenient 7/3 rise over run. And then I can use either of these points, so I can write y minus my y value of 4 equals 7/3 x minus your x value, which in this case is 1. And it's just that easy. So go ahead and try that on your own with the next two problems, 5 and 6 right down here. Start by identifying the points, at least one of them, find your slope, and then write it in point slope. So if we look here, we can find that one of my points is real easy, it's 1, 1. And then I can go from point to find my slope. My rise is a -3, and my run is a +4. So then I can set up my equation to be the y minus my y value of 1 equal to my slope, -3/4, times my x minus my x value, which is also 1. If you have not done 6 yet, do this on your own. So here I found that one of my points was +1, +2. Found that my slope was 3/4 by setting up my little right triangle here, rise of 3, run of +4, and then I can make my equation of y minus the y value 2 equal to my slope 3/4 times x minus my x value, and my x value there was 1. And that is all for that type of problem. The last thing that we have left to do here is using a table to write our equation. So take a second, investigate this, and see what thoughts you have about how we can use a table. So pause the video and take a moment. All right, we want to start here because I have all kinds of points. I have 4 different points to choose from. We want to find our slope. Well, to find our slope, again, we have to do delta y over delta x. And to do that change, I need to know the differences that are happening here. So notice my x's are not changing consistently. I change by 1 hour, 2 hours, and 3 hours. Now I just like to compare 2 different ones. I could compare all 3 changes if I wanted to. Right now I just chose to compare 2. So I have this change here from hour 3 to hour 5, and the gallons. So I take the change in the y, 2,500, and I just found that through subtraction, and the change in the x, 2, set that up. Now that is the same as the change in y here from hour 2 to hour 3, and that was a change of 1 hour. Since those are the same, I know that this is a linear relationship, and I was already told that this was linear, but we just want to make sure. So here is my slope of 1250 then. So once we know our slope, you should be able to write it in point slope form. So go ahead and try that if you haven't done it yet. And what I end up with here is y minus 3,320 equal to 1,250 times x minus 2, because I used this first point right here with a y value of 3,320 and an x value of 2. So that is all we have for today's lesson. So please make sure that you try the practice until you're confident, get at least half of it done, and check in with Pearson if you have any issues. Please let me know if there's anything else I can do for you. Aside from that, have a wonderful day.